going to do a video on divisibility and remainders, but I'm going to do a video on divisibility first. So this is really going to be a part one of two video. So part one, I'm going to take a look, and the best way to do this is to take a look at the number 360, because remember, there are 360 degrees in a circle, and it seems like a pretty important number. Especially since there's lots of round things around us. As a matter of fact, I'm looking at my lights right now, which are circular. So I want to know, can I divide the number 360 by the number 2? And the best way to do this is to look for patterns. And I bring this up because patterns are super, super important. So let's see. I'm going to do the first few multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I'm going to look for a pattern. Now, you should see, all right, well, let's see, 2, 4, 6, 8, 10. Okay, well, no pattern there. But after that, take a look what I have. 12, 14, 16, 18, 20. Oh, 22, 24, 26, 28, 30. So any number that ends in 0, where the last digit is a 0, 2, 4, 6, or 8, you can divide it by 2, which means 360 you can divide evenly by 2. And I'm not going to do it, but it's 180. So, by the way, if you can divide a blah, 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 if you can divide a number by 2, it is an even number. All right, so if you can divide it by 2 evenly, it is an even number. If you can't, then it's odd. So let's take a look at the number 3. All right, so I have, once again, I'm going to look for a pattern. 3, 6, 9, 12, 15, 18, 21, 24, 27. I'm not seeing anything yet. 30, 33, 36. All right, well, this doesn't look like there's much of a pattern here, but I'm going to take a look at this first column here. And if you look at this, I have 3, and then I have 12, and then 21, and then 30. Well, if I throw a little plus sign, a little addition sign in between them, 3 equals 3, 1 plus 2 equals 3, 2 plus 1 equals 3, 3 plus 3 equals, or 3 plus 0 equals 3. What? Let's see if that holds true. 1 plus 5, 2 plus 4, 3 plus 3. Wow, if the sum of the digits equals 3, 6, and let's see what happens when I have 9. 1 plus 8, 2 plus 7, 3 plus 6. Oh my goodness. So, if the sum of the digits equals 3, 6, or 9, you can divide the number by 3. Now, you might say, well, hold on, Mr. Amora. What if I had something like this? 3, 3, 3, 3, 3. 33,333. Obviously, you can divide that by 3. But let's see. I get 3 plus 3 plus 3 plus 3 plus 3, which is 3, 6, 9, 12, 15. Oh, but if I take 15, I get 6. 1 plus 5 equals 6. So, you might have to do it more than once. But it certainly does work. So, 360 would be 3 plus 6 plus 0, which is 9. So, I can divide 360 by 3. Check. I'm going to move on to 4. 4, 8, 12, 16, 20, 24, 28, 32. You know what? Let's move this over here. Let's see. 32, 20. Maybe it's not even going to matter. 28, 32, 36. This one's not as obvious, but I want you to realize that 4 is really 2 times 2. So if you can divide the number by 2 twice, you can divide it by 4. And there's actually an easier way of doing it. The other thing you can do is, remember when we were looking at 2, we only had to look at the last digit. The last digit. Here, if the last 2 digits can be cut in half twice, it's divisible by 4. So, with that said, I'm going to have to get rid of all of this. Ooh. So I'm going to take a look at the last 2 digits, which are 60. I'm going to take a look at 360. I'm going to take a look at the last 2 digits. And can I cut 60 in half? Sure. 60 divided by 2 is 30. Can I cut 30 in half? Sure. 30 divided by 2 is 15. So therefore, I can divide 360 by 4, and that will work. So I'm going to move on. I know I'm moving kind of fast. The idea is that you kind of have these rules on hand, so you will be able to use them when you need them. This one is one of the easiest. What do you notice? If the last digit is a 0 or a 5, you can divide the number evenly by 5. And because our last digit is a 0, then I can divide 360 by 5. Now, take a look at the number 4. We said that 4 is really 2 times 2, so if we can divide the number twice, we're in good shape. 6 is really 2 times 3. So, if the rules for 2 apply and the rules for 3 apply, then it can be divided by 6. So, is it even? Is it even? And do the digits add to 3, 6, or 9? So let's say 360 is even, and 3 plus 6 plus 0 equals 9. So because it's even, and I can divide it by 3, I can divide it by 6. 7's a tricky one. I'm not going to explain 7. 7's bizarre. So I'm going to skip 7. 8, I'm not going to really get into 8 either, except for I want you to know that 8 means, well, I will explain 8. 8 means I have to look at the last 3 digits and see if I can cut the last 3 digits in half 3 times. So I'd have to take a look at 360 and then see, can I cut 360 in half? Sure, I got 180. Can I cut 100? That's once. Can I cut 180 in half? Sure, I get 90. So that's twice. Can I cut 90 in half? Well, 90 is even, so we're still in good shape. And the answer is yes, so it's 45. So yes, because I can cut in half 3 times, I can divide by 8. Now 9 is 3 times 3. Well, if we look at the rule for 3, it said the sum of digits have to be 3, 6, or 9. So let's take a look real quick at 9. I have 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. Now, if I use the same rule for 3, you would say, oh, okay, well, they have to add up and be divisible by 3, 6, and 9. But 9 is a little bit different. The only numbers it adds up to are 9. So let's take a look. 3 plus 6 plus 0 equals 9. So I can divide 360 by 9. Check. And then 10 is the same as 5 and 2. It has to be even, and it has to end in a 0 or 5. Well, if it ends in a 5, it's not even, so it has to only end in 0. 10, 20, 30, 50. So yes, 360 can be divided by 10. Check. So I went through these rules very, very quickly. Obviously, you would have to practice them quite often. But I am going to do another video on using these rules to check for remainders, and it's actually kind of cool. So I will see you next time. That was video 1. I'll see you in video 2.